Swayam Prabha. Digital India. Educated India.
After finishing the VAMs and VAMs applications, that is PMUs, PDC and applications of PDCs, we come to the last part of the course where we will look at protection of apparatus. So, we will look at bus bar protection, transformer protection, generator protection and motor protection. So, these four important elements of what constitutes an electrical network, we will look at them over the next few lectures and then we will end the course. So, today we will look at one of the most important elements, which is the bus bar and protection of bus bars. So, bus bar protection. So, a bus bar will exist in virtually any network. It is where power is distributed. You have incoming feeders which bring power at whatever voltage level. It could be at even a low voltage level like 415 volts or 11 kV or 33 kV or even very high voltages like 400 kV or 765 kV. So, wherever there is need to distribute power, which meaning there are a few circuits which are bringing in power and few circuits which are taking away power. It could be transmission lines, feeders, transformers. A bus bar arrangement is required to distribute the power. So, there are various types of bus bar arrangements that are available depending on the importance, complexity, reliability requirements, etc. And then the protection of those bus bars will vary accordingly. So, we will have a look at some of the most commonly and most popularly used bus bar schemes as they are known as. So, the most basic of them is the single bus scheme, where you have a single bus bar and you have incoming and outgoing feeders. Now, we are for the purpose of this this lecture, we are not making any distinction between the feeders. They could be any feeders, they could be transmission line, there could be transformers, there could be feeders, any loads. So, motor feeders, we are not making any distinction per se. So, the first one is the single bus scheme. Single bus bar, or when I say bus I mean bus bars. So, could use it more compactly, that is the only reason why we say bus or bus bar. So, here there is no there is just a single bus bar. Okay, one bus and we will come to the application a bit later. Then there are various feeders that may be there. By feeder, I am not making any distinction between any transformer or transmission line or anything like that. There could be any generic feeder. Okay, this is one. Say there would be at least two, because there at least one incoming and one outgoing. Otherwise, it does not make much sense to talk in terms of busing arrangement. So, so, these are what are known as circuit breakers. Okay. So, if you remember the device numbers from one of the very first lectures, the IEEE device number for a circuit breaker is 52. Okay. So, these are the circuit breakers. These are disconnectors or isolators as they are called, switches basically. These are cannot interrupt fault current. For that the circuit breaker or the element number 52 as we can see is provided, and these are usually normally closed. NC means normally closed, NO means normally open. Okay. So, these are normally closed. Okay. So, why are they provided on both the sides? They are there to provide isolation. So, in case you need to take out the breaker for maintenance or something like that, then you will switch off the circuit from both the ends and then use the do whatever maintenance normally open. NC is normally closed. Okay. Now, you will have CTs most generally on either side of the breaker. Okay. This element represents a CT. I will write it once here and then we will use the same symbol. Okay. So, as you can see here, this is one of the most basic kinds of arrangement. There is no redundancy here. So, if the bus bar has a fault, then you will lose supply to all the circuits connected to it. On the other hand, if there is a circuit breaker problem, then that you cannot take it out for maintenance without affecting the supply to the feeder. So, there is no redundancy here. Whatever redundancy may be there in the circuits themselves. Suppose this is feeder 1 going to the same load and this may be feeder 2. So, there that much redundancy you can provide, but that is an external redundancy. In terms of the bus bar scheme, there is no redundancy provided. So, that is why it is less flexible. Flexibility is less as well as reliability is less. So, less reliable also. Okay. Now, where you have multiple circuits coming in, what is usually done? Okay. One more thing is if a bus this is usually will be there in low voltage metal clad switchgear and all that. So, usually only overcurrent relays will be provided, but if there is a bus bar differential scheme to be provided, then it will be provided like this. These CTs will be taken. We have seen that circuit breakers current transformers have to wrap around circuit breakers and these will be used, whereas for line or feeder protection these CTs will be used, so that there is an overlapping zone of protection. Okay. If I can draw with a different color. Okay. For feeder protection these CTs will be used. So, there is some, as you can see, there is some overlap. Okay. Now, we will come to the types of differential protection later, but I have just shown the scheme. The second scheme is single bus or single bus bar with sectionalization. Okay. So, what is done here is it is similar to a single bus bar, but you will have two sections of that bus bar. Okay. This is a breaker which connects the two sections of the bus bar. This is again two isolators, and then you will have knob feeders like we drew, multiple feeders. Here where there are larger number of feeders and there are two supplies available, generally then you will give one section, you will give one supply and the other section will be supplied from the other source. Two or more supplies are available, that this is used. And also since there are more feeders and more supplies, then the fault level could be more. So, this if there is only one bus, it could exceed the fault level of that bus. So, to to reduce the fault level or the fault rating of the equipment, we could sectionalize the bus. But in that case, these, if it is sectionalized for fault purpose, then this will have to be normally open. Okay. Then you have lesser reliability, but then in protection there will always a trade off between functionality and the cost that you are able to or that you are willing to bear. Okay. So, this is usually termed as bus say B and bus A, or bus 1 and bus 2, okay. And the normal CT arrangements will be like this, same as earlier, and this bus section breaker will also have 2 CTs, okay. And the protection for bus A will be in this zone like this. It will cover all the CTs and that zone, and for bus B will be, or bus 1, bus B or bus 2, whatever that you choose to call it, will be like this. So, there is some amount of overlap, as we said that there should be. So, this will be bus B differential zone, and this is bus A differential zone. Okay. So, the next type, now here also you notice there is some redundancy. If one section of the bus is gone, if there is a bus fault on this section, say on this section here, then this section can be taken out by this bus differential protection, and then but at least you have this bus A available. If there is a bus fault on bus B, then at least bus A is available, and some amount of continuity of supply can be maintained, not full continuity, but at least some amount of continuity will be maintained. So, this is the reliability here is more as compared to the single bus bar scheme. Okay. There is one more scheme involving the single bus bar. You can have now, for having complete redundancy, you will need 2 bus bars, so that if there is a fault on one bus bar, you actually that bus bar is taken out of service, but bus or supply continuity is maintained through the other. So, those involve 2 main buses. So, main 1 and main 2, but before that there is another type of arrangement known as single main or single bus and transfer scheme. Now, notice that in this, if there is a breaker problem, if either of this there is a breaker problem or breaker needs maintenance, then that feeder is lost. Okay, you cannot take a breaker out for maintenance. So, to overcome that, this this single bus and transfer scheme is used. So, you have what is known as the main bus, and there is one more bus, but it is not actually a fully functional bus. It can be used only for one feeder at a time. Okay. So, it is known as a transfer bus, and the arrangements is more or less the individual feeder breaker arrangements okay. So, here and the feeder will be connected to this. Okay. So, there will be multiple feeders like this. and the last one will be what is known as a transfer breaker. So, this is a 52. Of course, I am not written 52 everywhere, and here also all these are normally closed. Okay. Where I have not mentioned, please assume that the switches are normally closed. Okay. And the bus protection or bus differential zone will be okay. In this case, the advantage is, suppose this breaker has to be taken out for maintenance. Just as an example, this breaker has to be taken out for as a maintenance. Then this line will be put on transfer. So, these are normally closed. These are normally open switches. Okay. So, what will be done is this will be opened. These two will be opened. This breaker will be opened, and since this is closed, this switch will be closed. So, what is happening is the supply to this feeder is maintained through the bus through this route. Okay. So, in this case, the advantage is that the circuit breaker can be one circuit breaker, of course, can at a time can be taken out for maintenance. Okay. Then we come to the two bus schemes. Okay. So, the one with the most redundancy is the double bus, sorry. So, here in this is the scheme with the maximum reliability. Here you have two buses and two circuit breakers per circuit or per feeder. Okay. And the reliability is maximum, but keep in mind that the cost is also maximum. So, this is very rarely used, only when probably very important substations where it is used, but in India I have hardly seen it being used. Okay. So, these are multiple feeders like this. Yeah, it showed you how the feeder. Okay, one thing that we did not mention here is that there will be other than the current transformer, the voltage transformer will also be required, or a potential transformer will also be required, and here usually in this case there will be one provided on the bus. If there is a single bus or a sectionalized bus, then you will need two, one on each bus to know the bus voltage. Even in this case there will be one provided on the main bus. Okay. Now, this is the line or whatever is, these are the circuit breakers. All these switches are normally closed. Okay. Though there will be voltage transformers provided on the bus. Here we need we can't keep the line if it is the protection, if the distance protection is operated in zone 2, the line charged for a longer time. So, we will need some pilot communication. So, for that reason the line VTs will also be required. Okay. And the zone of protection for the bus will be like this. for this bus will be like this. I am of course not drawing all the feeders here, there will be multiple feeders. It is not definitely not used in a very small substation. So, there will be this is for bus 1 or bus main 1, and this is for bus 2 or main 2 differential zone. And for the line, what will have to be done is both these CTs will have to be summated. Okay. So, for the line protection, this will be the, because the current is flowing from either side. So, you will need a summation of for this line it will be like this and so on. Okay. So, these two CTs will be summated for the line. That is how the line protection will be done. You cannot rely on only one CT, because the feed or the current is flowing from both the ends. Okay. Now, before we discuss the other schemes, the one important aspect of protection of a bus bar is stuck breaker. Now, suppose if this breaker or one of the breakers gets stuck. Okay. Stuck meaning the protection has operated correctly, the relay has picked up on fault, it has sent the trip signal to the breaker, but because of some mechanical fault or some other electrical fault, the trip coil is not healthy or something like that, the breaker fails to trip. Okay. It gets stuck in the closed position. Okay. So, in which case the fault will be continued to be fed. So, to take care of this eventuality, or this is a very rare eventuality, but to take care of this one more relay is provided with the protection, that is 50 local breaker backup. Okay. This is an instantaneous overcurrent relay, and the timing is set such that if the fault continues, then this 50 LBB will operate a lockout relay which will open all the breakers associated with the bus bar. So, if there are, for example, in this section there are say 8 feeders like this, 1, 2, 8, then all the 8 circuit breakers will be opened. Of course, this in this section will be still, if it is still healthy, then it can continue to feed the fault. Okay. So, the next type is of course this if you, as you can see, is it takes two breakers per feeder or per transmission line or per transformer. This is for this line, for example, if this is the line that we are talking about, you need, this is one breaker and this is another breaker. So, to avoid or to have most of the flexibility, but to avoid the cost associated with one breaker, what we do is we have another scheme which is a slightly modified or I would say modified version of the double bus double breaker scheme, which is known as a 1.5 breaker. What was that number? 4. So, this is the 5th one, breaker and a half or 1.5 breaker. This is quite popular at UHV levels even in India, 1.5 breaker. Why 1.5? Because I will just show you, between two just rub this. Similarly, say one more like this. okay, and the feeders are like this, taken out from these sections here, and the same logic as protection of carrier aided protection for the lines applies. So, there will be line VTs also, VTs in this case also. The circuit breakers are of course around the breakers, sorry, I said circuit breakers, I said the current transformers will be placed on either side of the breaker. Okay. And the protection will be similar to this is the bus protection. Bus 1 differential zone, and this is bus 2 differential zone. Okay. And the line protection similarly will have to summate the currents from two cities. So, it will be so this will be the say L1 if it is the line 1, and then L2 will be okay, summating these two cities. Okay. The advantage of this is if you, as you can see between these two feeders, L1 and L2, we have got 3 breakers, 1, 2 and 3. So, we have saved the cost associated with one circuit breaker, which can be substantial at extra high voltage levels. Okay. There are see in this both double bus double breaker and 1.5 breaker, you can take a breaker out for maintenance without affecting the continuity of the supply. And also of course, there are 2 bus bars available. So, the redundancy in the bus is also there, but importantly a breaker can also be taken out for maintenance. So, there are 2 more schemes which I will just quickly mention before this number was 5, before we discuss the final scheme, that is the ring bus, but before that there is one scheme which is double bus or so here or 2 main also it is known as. Okay, here in this we do not I will draw it for simplicity's sake, I will make just a quick drawing. Here the redundancy in the bus is there, but there is no redundancy in the breaker. So, you can't take a breaker out for maintenance. Okay. But say this is main 1 or bus 1, main 2 or bus 2. Okay. So, this is another type which is used. Here you have redundancy in the bus, but breaker cannot be taken out for maintenance. So, it is not as flexible as the 2 that we just discussed. Then there is one more, you can add a transfer bus here and take a breaker out for maintenance also. Similar to single bus and transfer, you have 2 main and transfer. Okay. So, similarly you will have another transfer bus here. I will, okay, let us draw it very quickly. So, there will be 3, of course, here one thing that has to be mentioned here is that there will be a what is known as a bus coupler. I am sorry if I did not mention that. So, there will be a, so these will all be normally closed, and this bus is, just assume that this bus is extended, and there is a, this is a 52 known as a bus coupler breaker. Okay. Okay. So, the two buses are electrically connected to each other through this bus coupler, so that redundancy is maintained. Even if there is a fault on one bus, this will also of course have to be included in the differential protection, but otherwise the supply can be seamlessly transferred. So, now this is main 1, main 2 and transfer bus. So, in addition to I will have to draw it. Okay, so this so this was the arrangement with the main bus. Now, in addition to that, there will be a this is known as a bypass isolator, or so you can this is a different scheme. I will just rub this out. Let us not confuse issues. There is a scheme like that, but I will not. And there will be one more connection here to the transfer bus. This is correct. And then there will be a bus coupler, of course, which is connecting the two main buses. In addition to that, there will be a transfer breaker also. Okay. I will just rub this out because need to extend the buses. Okay. So, the transfer bus can also get the supply. Now, the final one is the ring bus. Okay. In this 7 is it 8. This is very unique. It is sometimes used, not very commonly used, but sometimes it is used in bus arrangements. You will see why it is known as a ring bus soon. Okay, so there will be lines here, of course, there will be voltage transformers. And one more line here. So, you can see that the physically or geometrically it is in the form of a ring, that is why it is known as a ring bus. Now, here the bus section between the transmission lines also forms the part of the line protection. So, there is no need to give a separate can see that this will form part of say line 1, then this will form part of say line 3, then this will form, this part of the bus will form part of line 2, and this part will form part of line 4. Okay. Okay. So, part of bus between lines forms part of line protection. Okay. So, there is no need for separate bus protection. Separate protection. Okay. So, now we will this is all about the bus bar arrangements. We will see the types of bus bar protection now. One thing that we should note is, we have discussed this before, this is again on a very rough schematic kind of thing. It is not, I am not drawing the actual bus bar arrangements, but just to illustrate. Say this is the bus, this is a bus arrangement, and there is a fault here on this feeder. So, this CT will see the almost 3 times the current that is seen by the other 3 CTs, and this could saturate on fault. So, and then the I1 plus I2. So, the fault is outside the zone, because the we have seen what happens when the CT saturates. Okay. The relationship between the primary and the secondary is lost. It starts behaving like an air cooled reactor, and on a circuit level all the current will flow through the magnetizing path, and then it is not reproduced faithfully, and the relay will not see the current. So, this will not be equal to 0, and even when there is no fault, a fault will be seen. Okay. So, there are ways of overcoming this. You have then you have restraint. The CT saturation curve is of course like this. If you see the V versus I characteristic, we have seen that the V versus I is characteristic is like this. I restraint and I def, and then you can have a varying slope. So, this is known as the percentage differential characteristic. So, the types of differential protection, the first one is the multi restraint. This is of course, we are talking specifically of bus bar protection. So, this is the most versatile form of bus differential protection. Okay. Each manufacturer, means there are various manufacturers. So, each manufacturer has their own, or his or her has different application. Let us say not, let us not get to, has different application criteria. So, Here what happens is instead of one restraint winding, you have multi-restraint relays or multi-restraint winding in multi-restraint relays. Restraint winding is connected to each circuit or feeder which is a major source of fault current. Okay. If there are feeders with low fault current, so circuits with low fault current the restraints may be paralleled. And they are set in such a way that if there is a high fault just outside the zone, the restraint will be able to block the relay from operating. Okay. So, this is the multi restraint relay. The second one is the high impedance differential relay. So, here what we do is we make use of the CT saturation itself. It is a Russian technique known as TRIZ. I mean this is not that, but it is a technique of systematic innovation. Made a spelling error. Systematic innovation, in which you extend the harm that it can do and then exploit that harm for finding the solution. So, what is done is, say there are I am not drawing all the breakers and just drawing the CTs. Okay, so, now all the CT currents are summed into the this is just drawn schematically into the relay. Okay. So, this is okay, and what is, suppose this CT there is a fault here and then this CT saturates. Okay, that means its impedance goes down drastically. Now, what is done is a high impedance or a high resistance or an impedance is inserted in series with this relay, okay, with the differential relay. So, the impedance of these two circuits, rather there are 4 here. So, say the impedance of this one, this circuit and this circuit is very high, while the impedance of this circuit is very low. So, what will happen is all the current, the summation of the 3 currents, instead of flowing through the relay, will now flow through the CT with the lower impedance, and then the very low differential current will be available here. So, that this relay will not operate. Okay. So, this is making use of the saturation of the CT itself to find a solution. There are of course a few nuances or engineering wise that has to be taken care of. High current flowing through this can cause a high voltage to be developed and some flashover, etc. So, there is a nonlinear surge protector that is usually provided also in series with the high impedance. So, that is known as a metrocell or some, but that is an engineering aspect, we need not worry too much about that aspect now. Okay. The last one is of course with numerical relays. With numerical relays they have a very very low burden. So, this scheme is not very suitable to use with numerical differential relays, but with numerical relays we can use a sample to sample comparison. So, that can be very fast. Okay. So, here what happens is instead of waiting for the we saw that for phasor computation the relay will require at one cycle or at least half a cycle. So, instead of waiting for the whole phasor to be computed, the samples which are available they are compared, and on basis of because the bus bar is in a closed in a physical location which is very compact, compact in the sense that it is not hundreds of kilometers away like a transmission line or even like a transformer where it can be some 50-60 meters away, the two terminals. The bus bar can be compact in that sense. So, that is why the sample to sample comparison can work in this case. Here the samples that are obtained, the numerical or the digital samples that are obtained are compared to each other, and a very fast decision can be got even in quarter cycle. Okay. So, before the CT can saturate, you do not allow the CT to saturate at all. Okay. Before the CT saturation, the sample to sample comparison can be done, and there is of course a danger of it operating on transients also. So, a transient monitor can be provided which can increment a counter if there is a fault detected. Okay. Next cycle if there is no fault detected, then it will decrement the counter, and again if the fault persists, then the counter will be incremented again, and then if once it crosses a certain threshold, then it will trip. So, that transient monitor can function in that way. Also you can have some numerical because this is a numerical relay, you can have a phasor model of the CT which can, or a sinusoidal model which can approximate the sinusoidal current in the next cycle, and if it does not match because of saturation, then appropriate action can be taken. So, we saw the 2-3 techniques for bus differential protection. We will take up another apparatus protection next time. For now, this completes our discussion on bus differential protection.